Any ideas on what current is?
Amount flowing through the circuit?
Yes. So it's the flow of charge, the flow of electrons. Do y'all know the unit of current?
Amp.
Amp, yes. So what else can we write an amp as?
A milliamp.
So an amp is actually also a coulomb per second. Does anyone know what a coulomb is?
It's like a mole of electrons.
Basically, yeah. So a coulomb is, like Brett said, a mole of electrons, but it's just a unit of charge, basically. And so if we have coulombs per second, we know that current amps is basically just the rate of flow of charge. So if we go back to our excellent water tower analogy, it can be used to explain every electronics concept. Basically, if I have the speed of your water flowing through that is going to be current. And so you can sort of tell. Alright, so now that we know current, voltage and current are tied together in several ways. One way that they're tied together is power. So power is just voltage times current. And the symbol for current is actually I. And the abbreviation for amps is A. So power, think of charging your phone. You've heard of the different amperages of chargers, like those 5 amp chargers, the 10 amp charger. So your phone uses power, right? There's power stored in the phone's battery. And then you have a voltage coming out of your wall, right? And so this basically determines how much power is being received by the phone at one time. So power is really kind of the charge it's receiving at one time. And so you have a charger of 5 amps, 10 amps, 15 amps, and that's going to increase your power. Another way that current is related to voltage is this nifty formula, V equals IR. This is Ohm's law. So this is kind of fundamental to understanding pretty much every electronics concept there is out there. So this is voltage equals current times resistance. And so let's take a very basic circuit. So we've got our battery. Actually, I'll introduce you to some of the symbols. This is a symbol for a battery in a circuit. This long line followed by the short line. And let's say we have a resistor connected to it. So we would call this putting a load across the battery. And so in the circuit, let's see, give me a voltage value for our battery.
100.
100. Very realistic. And let's say I have a 50 ohm resistor. Ohm is the unit of resistance. What would my current be? using V equals IR. This is the resistance, this is the voltage. 2. So you get 2 amps. And so a circuit like this can kind of show the relationship because resistance is how hard it is for electricity to flow, right? So if we, let's say we change this to 1 ohm. It's really easy for electricity to flow, right? And so your flow rate is going to be higher. So you'll get a larger current, right? 100 amps or something. And if I make it harder to go through with a resistor of 100 ohms, I'm going to get 1 amp. So a lesser rate of flow. And you can kind of tell, basically, you can kind of get a sense of why that is using an example like this. So any questions about all this? Nope. All right.